Hi, General Chemistry. Today we're talking about strengths of acids and bases. So a lot of times we think how strong is an acid or base? We might think, does it burn me? Will it not burn me? But there's a little bit more chemistry to that. So let's start with acids. A strong acid is defined as ionizes almost completely in aqueous solutions. It's a strong electrolyte, which means it would conduct electricity very well. By ionize, it means when you dissolve it in water, those ions break apart. So it's made up of ions. Let me get my pointer. Okay, so if we have something like hydrochloric acid, which is HCl, so that's the formula. It's made up of one hydrogen and one chlorine. So if I put this into a beaker, we'll say, so here's a beaker of water. What I'm going to get inside, so I'm going to do a zoom in box. So if we zoom in on what would happen when I put HCl in water, the positive hydrogens, because they donate an electron, and the negative chlorines are going to break apart. So we're going to have ions floating around in water. They do this because of water's polarity. Remember, water has a positive and a negative pole, so it's going to pull these guys apart. That's what we call ionization. So when we put that beaker on that electrode and the light bulb lights up, this is why. Okay, so all it means when it says a strong acid or a strong base, it just means that they completely ionize. They're strong electrolytes. Some examples, hydrochloric acid and sulfuric acid are both examples. Remember, we can tell it's an acid because it has an H in front, starts with a hydrogen. A weak acid does not ionize or partly ionizes in an aqueous solution. So here's some examples. Phosphoric acid, acetic acid, which is vinegar, carbonic acid, which occurs in soda. And let's take a look at these pictures. So, like I said, here's hydrochloric acid. What's happening here is the little blue ones, those are the hydrogens. They're breaking apart from the hydrochloric acid and they're going to bond with water because water has that pole. So it bonds with water to make hydronium ions. And then chlorine is this negative green dot floating around. So notice they're completely ionized, completely broken apart, while something like vinegar, which is acetic acid, doesn't really break apart. All these molecules, 1, 2, 3, 4, 5, 6, 7, 8, 9, are all together. They didn't ionize, they didn't break apart. But one out of those 10 total broke apart. So we have 10 molecules, only one broke apart into its ions. So only charged particles can conduct electricity. Okay? So that's why this guy is a weak electrolyte, won't conduct electricity very well. Weak acid, weak electrolyte. Let's talk about bases then. Strong base or weak base is determined again on dissociation, which means to break apart, or ionization. Dissociation and ionization, same thing. So here it says, you may have noticed metal or bases are made of metals and nonmetals. So if we have something like potassium hydroxide, if we look down here, our picture here shows sodium hydroxide. So here's sodium hydroxide. The sodium and the hydroxide, when we put them in water, totally break apart. So we have positive and negative ions in solution. Then a weak base do not completely dissociate, do not ionize in solution. So something like this guy, okay, oops, sorry about that, doesn't break. The nitrogens and the hydrogens stay together and then has one oxygen in there. So now we see that they partially ionize. So out of 10, only one ionize. So all has to do with how those molecules break down in solution. Okay, strong bases break down totally, dissociate. Weak bases don't. Same thing with the acids. All right, now we need to talk about the pH scale a little bit. We've mentioned it, you guys know what it is, but maybe you don't know exactly what does pH stand for. What are we measuring when we do say pH? It's a convenient scale that can be used to describe the concentration of hydronium ions. So that's when the hydrogen gets donated and bonds with water in a solution and how acidic it is. So pH stands for this French term. Can't say it, not going to try to say it, but it's French, and it means hydrogen power. Okay, so it's the power of hydrogen. pH means hydrogen power. So a little bit of math. What we do, this is hydronium, and the brackets mean concentration. We take the negative log of the concentration of hydronium ions. So in other words, we're basically measuring concentration. All right, here's a little background on the math. The logarithm of a number is the power to which 10 must be raised to equal that number. So it goes up in units of 10. A neutral solution at 25 degrees Celsius, which is about room temperature, has 1.0 times 10 to the negative 7th molarity, which is a concentration of hydrogen ions or hydronium ions, or a pH of 7. So this would be a neutral solution. It's a measure of how much hydrogen is in that solution. Okay, it's a little bit of math. I'm not going to ask you to understand this math or to do this in class, but I need you to realize that we're measuring hydrogen. So pH is measuring hydrogen. That's where we come up with this scale. Okay, we've already kind of talked about this, but 7 is neutral. Okay, 7 is neutral. Anything under 7 is acidic. Okay, so that have a lot of hydrogen, and anything over is basic, so it wouldn't have much hydronium. Okay, so alkaline again means base. And I think that's where we're going to stop for today. Oh, wait, one more. We use the pH scale most of the time. There's also what's called the POH scale. So pH scale measures how acidic something is, measures the hydrogens or the hydroniums, but POH takes a look at the hydroxide ion. So it's defined as the negative of the common logarithm of hydroxide ions. So it's the same thing, except instead of measuring hydrogen or hydronium, we are measuring hydroxide. Okay. So we usually don't use this scale. We use pH more often than not. Okay, but there is a scale. And as you would expect, if we're measuring hydroxides, the neutral is still 7. But if we look here, more basic is, oh wait, hold on. Here's the sorry, this has a multiple scales. Here's the pH. If it's basic on the pH scale, it'll be 7. This goes up to 15. And then if we're on the POH scale, if it's more close to 1, it's going to be basic. So it just depends what scale we use. We're going to always use the pH scale, but just know that there is a pH and there is a POH scale for measuring acidity. All right, that's it for today. We'll see you in class. Thanks, guys.